Let's look at solving rational equations. We've been studying rational expressions and complex fractions. Now we're going to look at rational equations. So as a quick review, let's go back to domain versus domain restriction. The domain restriction, I'm going to abbreviate, in any rational equation is the values that the variables cannot be, and the domain consists of all the other values. So the domain is the values that the variable can be. Now there's steps listed here for how to solve a rational equation, but I think what I'd like to do is just sort of walk you through one first. You can glance up at the steps to see that I'm following them, but the first thing you always want to do is determine the domain restriction. The reason is by the time you get finished and you actually have a solution, you're going to be so ready to move on to the next one that you may forget that you need to check your answer against that restriction. So looking at our denominators, I know here that x can't be 0, and I know here that x can't be 0 because it would be 2 times 0 is 0. That would cause zeros in those two denominators. With the 2 here, there's no restriction because there's no variable. So when I go over here, I've set it up to make it easy for you to remember what to do. The domain restriction is that x cannot be 0 in this case, which means that the domain is everything else. So how do you write that? Well, we write it in what is called set notation. So this symbol means the set of all x. You write that x, then you make a straight vertical line, and that is read such that. The set of all x such that x does not equal 0. And what that means is it's the set of all the other numbers except for 0. So once you have your restriction, you should be able to write your domain by just adding this set notation. The set of all x such that x does not equal 0. Next, I need to find my LCD, just like we did with the complex fractions and adding and subtracting rational expressions. So I need to know x, 2, and 2x, what it would take for each of those to cross cancel, or what do they all go into. And in this case, my LCD is 2x. So I'm going to rewrite these. I'm going to take my 3 terms of my equation, and we're going to use this LCD in a way that's different than when we added and subtracted. There we changed all the fractions to fractions that had the LCD. We're going to use it in the same way we did with complex fractions, where we multiply each term by the LCD in order to get rid of the denominators. So I'm going to write my LCD here. If you need to put it over 1, go right ahead. Now we're going to cross cancel. The x's cross cancel, and I have 2 times 2 is 4. The 2's cross cancel, and I have a 3x left, 3 times x, equals, that cross cancels, and I have a 7. Now what you have is a linear equation in one variable. There's nothing squared. So my goal is to get variables equal to numbers. So I'm going to subtract a 4 from this side to isolate that variable. I get negative 3x equals positive 3, divide by the coefficient, and I get x equals negative 1. Now, before I write it on the line that is my solution, I have to compare that. So I'm going to write this. Compare my solution to my domain restriction. I have to make sure that I didn't get an answer that's disallowed. Well, I didn't get 0, so we're okay. So my solution in this case is x equals negative 1. So that is the process. Determine the domain restriction, multiply each side, I'd rather say each term of the equation by the LCD, solve the resulting equation, check it against your domain restriction. Let's try another one. Here I have x minus 3 in my denominator, x plus 3, and x squared minus 9. In order to determine my domain restriction, I'm first going to need to factor this difference of squares. And now I have to look at, just by inspection, what it is that x can't be, because it would cause a 0 in the denominator. So in this case, x cannot be 3, so x cannot be 3. And in this denominator, x can't be negative 3, because if it were negative 3, we'd have negative 3 plus 3 makes a 0. And then in this denominator, it's just a repeat of the other two. So I already have that taken care of. So my domain restriction is x cannot be 3 or negative 3, which means my domain is the set of all x such that x does not equal. Now I'm going to show you how you can write it when it's a plus or a minus. You can just write plus or minus 3. That's kind of a little shortcut way to write it. My LCD has to represent each piece, so I need an x plus 3 and I need an x minus 3. I'm going to rewrite my terms. X minus 3, 3 over x plus 3 equals 12 over x plus 3, x minus 3. Now I'm going to put each term in parentheses. Since there's already parentheses here, I'm going to use brackets. And beside each of those, I'm going to write my LCD. X plus 3, x minus 3. Now that's all over 1. I'm just having to squeeze it in. I'm going to have to squeeze it in here too. X plus 3, x minus 3, like that. X plus 3, x minus 3, like that. So you can see there in purple that I've written each LCD. Now what happens is every denominator will cross cancel if you picked your LCD correctly. So 2 times x plus 3 is what's left in that term. 3 times x minus 3 is what's left in that term. And here I just have a 12 left. I'm going to distribute 2x plus 6. Distribute your negative 3. Be careful, negative 3 times negative 3 is positive 9. Going to combine like terms. 2x minus 3x is negative 1x plus 15 equals 12. Now again, because my variable isn't squared, this is just a linear equation in one variable. So I'm trying to get variables equal to numbers. So I'm going to subtract a 15 from both sides. I'm going to move up to here so you can still see. I get negative x equals negative 3. We're going to divide by negative 1, and I get x equals 3. And before you get all excited about having just solved this rational equation, go back to your domain restriction. X is not allowed to be 3. And that's what I got. So our solution is no solution, or another way to write that is this symbol, which means the empty set. There's nothing in the solution set because there is no solution. So always you have to compare what you get to your domain restriction. All right, let's try another one. A little more complicated. The reason it's more complicated is because each of my denominators needs to be factored before I can tell what my domain restriction is or what the LCD is. So here, this is a trinomial short. I'm looking for factors of negative 2 that combine to make positive 1. That's positive 2 and negative 1. So it's p plus 2, p minus 1. Here I have difference of two squares, p plus 1, p minus 1. This is all running together. And then this one is another trinomial short. So I'm looking for factors of positive 2 that combine to make positive 3. So it's 2 and 1. So that's going to be a 2 and then times p plus 2, p plus 1. So there's a lot of pieces to my denominators here when I go to find my LCD. Let's look at what it is that p cannot be. What domain restriction do we have? So let's look at the first piece. Here, p can't be negative 2. So p cannot be negative 2. Here, for this one, p cannot be 1. Here, p can't be negative 1. Here, p can't be 1, but I already have that. Up here, p can't be negative 2, but I already have that. And here, p can't be negative 1, but I already have that. So those are my domain restrictions. P can't be negative 2 or plus or minus 1. So I'm going to write that the domain then is the set of all p such that p is not equal to negative 2 or plus or minus 1. Those are the things it can be. Anything except those numbers. Now, the LCD has to be something that represents every piece of every denominator, including that 2. So the first piece of my LCD is 2. Now I'm just going to go down the line and make sure everyone is included. I need a p plus 2. I need a p minus 1. I need a p plus 1. I need a p minus 1. I already have it. I got my 2. I need a p plus 2. I already have it. P plus 1. I already have it. So my LCD is quite long. So because of that, let's rewrite each term with the factored denominators so that when we use our LCD, we can see exactly what is going to cross cancel. Equals 7 over 2 times p plus 2, p plus 1. All right, now I'm going to use a different color because this is going to get very cluttered. So each of these terms I'm going to put in brackets since the parentheses already exist. And beside them, I'm going to write that whole LCD because I'm going to multiply by that. So there it is with the first term. Here I'm going to have to squeeze it in. A 2, a p plus 2, a p minus 1, and a p plus 1. Just kind of stacking it up. Here it's a 2, a p plus 2, a p minus 1, and a p minus, plus 1. I think I have them all correct. So they're just sort of jumbled up, stacked beside each term, knowing that it's all over 1. So here, p plus 2 cross cancels p plus 2. P minus 1 cross cancels p minus 1. So look carefully. What's left is a 2 times 3, and that's going to be times p plus 1. All right, here, p plus 1 cross cancels that, p minus 1, and I have a 1 times 2 times a p plus 2. Looks a lot simpler on this line, doesn't it? Here, the 2's cross cancel, p plus 2, p plus 1. What's left is a 7 times a p minus 1. So that's what's left after we got rid of all those denominators, a much more manageable equation. So let's go ahead and multiply 6 by distributing 6p plus 6. Here I'm distributing a negative 2 minus 2p minus 4 equals 7p minus 7. Combine like terms. 6p minus 2p is 4p plus 2 equals 7p minus 7. Once again, it is a linear equation in one variable, so all I need to do is get variables on one side and numbers on the other. So that gives me 2 equals 3p minus 7. We add a 7 to both sides, and we get 3p equals 9. We divide by 3, and we get p equals 3. Maybe. We have to go back to our domain restriction and check. Is it allowed to be 3? Yes, it is. So that is our solution. P equals 3. It actually worked this time. All right, I want to show you something at the bottom because I think this is really important, and that is a comparison of simplifying rational expressions where there is no equal sign, there is no equation, and then solving a rational equation. where we do have an equal sign. They're similar, but first thing I want you to notice is the directions are different. One says simplify and one says solve. So let's do the simplify first. I need to factor this denominator in order to tell what my LCD is. So in this case, my LCD is going to be a y times a y plus 3. So what I'm going to do is I'm going to write what I already have. I'm going to put it over the LCD that I'm trying to get to. Write what I already have, put it over the LCD that I am trying to get to. Now, this is not what we've been doing in this lesson. This is a review of another lesson. I'm not going to multiply by the LCD. I'm going to say, what do I need to do to get to that LCD? Well, this denominator was already like this, so I need to do nothing to the 15. This denominator was not already like this. It's missing a y. So to get from here to here, I had to multiply by y. So I have to do the same thing to my numerator. Notice my denominators didn't go away. Now that I have a common denominator, I can write my numerators combined over that common denominator. So 15 plus 5y. Now, am I finished? Maybe, maybe not. I need to factor that numerator and see if there's anything that will cross cancel. So I factor out the GCF of 5. I'm left with 3 plus y over this. I can cross cancel 3 plus y over y plus 3, and what I am left with, simplified, is just 5 over y. My point with this one is, when it says simplify, and there's no equal sign, your denominators are not going to go away. You're going to end up still with that common denominator, and then after you factor, perhaps something will cross cancel. But those denominators are there. All right, let's contrast that with, on the other side, our directions say solve. And I do have an equal sign. So this factors the same as it did before. I can see that my LCD is going to be the same as it was for the last one. So let's rewrite our terms. 15 over y times y plus 3 plus 5 over y plus 3 equals 10 over y. But here is the difference. Because it is an equal sign and I am solving, I'm going to put each term in parentheses like we did on the rest of this lesson, and I'm going to multiply each term by the LCD so that the denominators will all cross cancel. That didn't happen when it said simplify. So what happens here, y cross cancels y. All I'm left with is a 15. Here I'm left with a 5y. Here I'm left with a 10 times a y plus 3. 15 plus 5y distribute equals 10y plus 30. And now I don't have a fraction anymore over a common denominator. I have an equation that needs to be solved. So I'm going to subtract a 5y here. That gives me 15 equals 5y plus 30. I'm going now to subtract my 30, and I end up with 5y equals negative 15. Divide by 5, and I get y equals negative 3. But what did we learn? When it's an equation, I'm not done when I think I'm done. I have to go back and see what the domain restrictions were. So, domain restriction. Y cannot be. Here, it can't be 0. Here, it can't be negative 3. Here, it can't be negative 3. Here, it can't be 0. So because my domain restriction says y can't be negative 3, and I got negative 3, then my answer here is the empty set, or no solution. because of my domain restriction. So I want you to really look at the difference between this green problem, simplify, and the blue problem, solve, because they are similar but very, very different.